Oh,
Okay.
I see.
Okay, and they took a circle of 1 through 9 and said that that circle is a result of dividing by 7. Okay, I'll give everyone an example again of dividing by 7. Take 2, divide it by 7, you get 0.285714, okay? So it's 0.28, what was it? 0.2857. It makes that shape.
Right.
Okay, so I then took, instead of doing a circle of 1 through 9, I made my circle based on the toroid skin backwards, which I call the antithesis of the toroid. And I then connected the numbers of my doubling circuits like I knew to do, right? Which is 1, 2, 4, 8, 7, 5, which makes the integral. I found that this is a real popular shape. I just wanted to show you that it was connected. This is on the pharmacies throughout the world in front of buildings. It's a hidden mystic occultist type symbol.
Yeah. But 1 and 2 are connected in yours, and 1 and 4 are connected in
No, I'm not trying to make dividing by 7 in mine.
Right, I know, but
I'm trying to show that that doubling
yours are mod 9,
circuit.
and
shape
yours
is
are mod
exactly
7.
the same.
Yours are mod
No,
9.
they're mod 9 too. They're all mod 9
Yeah,
dividing
they
by 7.
are.
Yeah.
But we started with mod. We started doing 7.
No, we didn't. We just divided 1 by 7.
Yeah.
Okay, all I did was take 1 and divide it by 7. And I got that pattern. I'll go further. What does that pattern mean? We have multiples now. Okay, now that pattern, no one's ever been able to say. They say it's an infinite pattern. They don't. Okay, I found that it can. Huh?
That's a repeating decimal, though.
It's a repeating, and I found that repeating decimals can be given a discrete number value of such as the repeating decimal of 0.142857 equals a 4. Want to see how I figured it out?
So all those times when your teacher said, "Oh, that's a repeating decimal," yeah, but it really means this number.
How do you do
Yeah.
It is a repeating decimal.
Want to see how I figured it out?
Yeah, but it's also
Okay.
a 4.
It can't be adding them together because 2 divided by 7 is the same series. It just starts at 0.285714. So I didn't add them
So it
together.
changes.
I'll tell you how I did it.
Permeates the group.
You ready? I knew I took 7 divided by 7, which was 1. Okay? It's really this easy. All you have to do is say the third number, or the second number before 9 is a 1 here. So the second number before 9 on its reverse mirror must be an 8. So if we divide a number by 7, 1 through 9, which is our control, if we take 7 and divide it by 2, we get an 8. We also know that 8 divided by 2 is 4. So if this is a 4, then this number over here must be a 5. Okay, and then I said, well, if 0.142857 equals 5, I have a 1 right here on the other side of the decimal that I'm adding to 142857. So 1 plus 142857 equals 5. That would be 1 plus 4. It's kind of like weird algebra.
Yeah.
So I then take 142857 and say that's an equal to a 4 up here.
Right.
And sure enough, multiples of 5, the last number will be 4. 5, 10, 15, 20, 25, 30, 35, 40. It's too easy. Okay. So sure enough, this is multiples of 4. And because I did dividing by 2, which is multiples of 5. 1 divided by 2 is 5. 2 divided by 5 is...
Would you say
2 divided by 2 is 1.
How did you get 5 again? You got 7 divided by 7 equals 1. Then you said 8 divided by 7 is what now?
8 divided by 7 would have to... All I did was go divide 4... Where's the multiplication I was using? Oh yeah, dividing by 2. Because 2 and 7 are my polar numbers.
Right.
So I went over here, and I knew that I could divide by 2, because 2 and 7 are mere opposites.
Yeah.
Okay, and it would give me the reverse multiplication series in the opposite direction. Because I don't have a repeating decimal and dividing by 2s, I had 5, 10, 15, 20, which is 5, 1, 6, 2, 7, 3, 8. So I knew that dividing by 7 must be the reverse mirror, which is 4, 8, 3, 7. So if I made this a 4, then I made 0.285714 and 8. So I go down to over here where it's 0.28714, and sure enough I add it with which equals an 8 with 1, and that equals a 9, and it worked. There's all different ways you can prove it to be true. But it wasn't hard to do. Okay, so these patterns all mean something. All this stuff's connected. Anyway, I just wanted to show you how did we get onto dividing. We got on it by the integram. We got onto it by the shape. Okay, dividing by 7. Okay, I just wanted to show that I had cracked the code to the integram because I like to tie in different things to the code. That's the trick. Bringing numbers and geometry and surface topology and particle physics and spirit and biologics, everything together in computers.
Just be like this.
Thank you very much.
Mahalo. You guys are a lot of fun. Couldn't have more fun.